Okay, in this section we've been talking about some different transformations. We talked about um, moving or translating, and we talked about rotation. And there's one other called mirroring. Just to start out, let's do an angle. So when this angle is congruent to another angle, we can show that they are congruent if they are the same size and same shape. Okay, so these two are considered congruent. And congruent is same size, same shape. Okay, so the way you can show something is congruent is if you can use some of those transformations, or we also call them isometries. If you can use a series of isometries to map them on top of each other, then they're considered congruent. So this I could translate and then rotate, and that would show that the two shapes or two angles are congruent. So this is, I used rotate, and translate. Those are two of them, and then the last one is mirror. So I could mirror this one and translate it. And actually, usually you would mirror twice if it's a different kind of shape. Usually you mirror here, and then I mirror again, and I end up on top. So mirroring is another isometry. Oops, I'm off the page here. Okay. What else is there? There is also scale. Now scale is not associated with congruence, but if I had a shape, let's say I had a star, and let's make another star. So this, I will make this star congruent to this star as best I can. Oops, it's kind of off there. Okay, so these two stars are congruent, but you might see some stars and say, oh, well, that star's fatter than that star. Well, they are still congruent. I just have to turn it the right way. So this is a rotation and a translation, and I get that. Now you notice that if I mirror this star, I can't line it up. It's actually different. But if I mirror and then I mirror again, so that is a set of isometries. If I do multiple isometries and I come up with a way that I can map it on top of the other one, and they are the same size and same shape, then they are congruent. So even though you might see this star and this star, you can say that they are congruent because I could mirror this star and come up with that star. Okay. Now, to talk about scale, scale is a little bit different, and similarity. So one of the tricks I know about scaling is if I draw some lines that are shooting out from a point, going through each point. That one, it's pretty close, and that one. Okay, and then if I wanted to maybe make another star that was twice as big, I could double this length. So from that point to this point gives me a point, and then if I double this length, and I double this length, and I double that length. And finally, double this length. Okay, it should give me a star that is twice as big. And this star is not congruent to the other star, but we would, so I cannot map, no matter what I do, this star onto that star. But what I would say is these two stars have a similar shape. So similarity is defined as same shape, but not the same size. Okay, and that isometry we call scaling. Okay, so we have similarity, congruence. If something is neither similar nor congruent, so let's say we had a 6-pointed star, so this would not be similar or congruent to either of these stars. So this is not equal. Okay.